In this session, we shall be talking about the outcomes of squares. So let's start. Now, when we say that we are talking about the outcomes of squares, what we intend to convey here is, let us assume a natural number, the square of which gives me a perfect square, and in that case we are going to talk about the units digit in the perfect square of a given natural number n. This is the first thing that a learner needs to think about once the learner is already aware of how to calculate a perfect square. I repeat, now this learning comes into picture only once I have undergone the basic way of calculating the squares of numbers. Now when I say squares of numbers, I am basically referring to natural numbers or integers, and at the same time I am referring to non-integers as well. But in this session, once we have undergone the basic know-how about how to calculate a perfect square, here we are going to talk about the outcomes of the squares of natural numbers. So you would see that here we have taken a natural number n, and let us assume that there is a central processing unit, CPU, which is responsible to calculate the squares of the natural numbers that we are inputting from one side, and on the other side you would see that the output is the perfect square, which is n square of that natural number n. Now the unique observations which would follow after this is, let's see that. Now if I have a 0 as the units digit of the natural number that I'm inputting, naturally the outcome of the perfect square will also have a 0 in the units place. For further discussions, the line that we have drawn beneath a digit, kind of a slot, or you can say a line that we have drawn, is to symbolize a units digit, right? Okay. Now if I would have inputted a natural number having either a 1 or a 9 as its units digit, its perfect square will have 1 distinctly in its units place. If I'm inputting a 5, then the perfect square will also have its unit digit as a 5. If I'm inputting a natural number which has either a 2 or an 8 in its units place, its perfect square will give me a 4. If I'm inputting a natural number which has either a 3 or a 7 in the units place, its perfect square will have a digit 9 in its units place. Last but not the least, if I'm inputting either a 4 or a 6 in the units place of a natural number to find out its perfect square, then its perfect square will have a 6 in its units. So you would see there are 6 cases which are made, and the digits that I have inputted as the natural number or in the natural number in the natural numbers units place, which are written in black color, are 0, 1, 5, 2, 3, 4. And then the digits which are written in the blue color are nothing but complements of 10. This is just an observation which needs to be done by a learner after a learner comes across a new concept. And this observation, I feel, is mandatory for a learner like me, because if I observe things, then I do not need to subscribe to rote learning. So if I know the outcomes of 0, 1, 5, 2, 3, 4 being inputted in a CPU, and then the outcomes in terms of perfect squares of these inputs. I know that 0 square gives me a 0, 1 square gives me a 1, 5 square gives me a 5, 2 square gives me a 4, 3 square gives me a 9, 4 square gives me a 6. I as a learner can decode the remaining 6 cases as well. So after I have learned this concept, let us see what are the byproducts of the learnings. So the first byproduct here is, as we can see in terms of the green outcomes that we have got, green here refers to the color. So a perfect square has 6 unique outcomes in its units place. The second observation should be, now 3 of these unique outcomes are even numbers. Now when I say even numbers, a number which has an even number in the units place is what I am talking about. So n square has a 0 in its units place, it has a 1 also, it has a 5, 4, 9, 6. But 3 even outcomes or 3 outcomes which are even numbers which we are talking about here are n square having a 0 in its units place, or a 4, or a 6. The remaining 3 outcomes are odd number outcomes, and those outcomes are a perfect square n square having either a 1 or 5 or 9. Next important outcome or byproduct that we can talk about here is any number with these 5 digits, which is 0, 1, 5, 4, 6, 9, may not be a perfect square. Let me spend some time on this. Now if I'm inputting a number n in a CPU which is responsible to find out the perfect squares, naturally the outcome is going to be an n square. Now if the outcome is an n square will categorically have these 6 unique outcomes, which essentially leads to having either a 0, having a 0, 1, 5, 4, 9 or 6 in the units place. But point number 4 that we are talking about here is any number with these 6 unique outcomes may not be a perfect square, which is the converse of this. Please keep this thing as an important outcome. Now this is the point that we have made earlier, which is, now if you would refer to the 6 inputs that we had done, and those inputs that we are referring to have been indicated in terms of the black colored digits and the blue colored digits for that particular row. For example, 0 plus 0. So don't understand it as, you need to understand it as 0 plus 1, 0 is a 10, 1 plus 9 is a 10, 5 plus 5 is a 10, 2 plus 8 is a 10, 3 plus 7 is a 10, and 4 plus 6 is a 10. So if I know the outcomes of the digits which have been highlighted by a black color in the units digit of the given natural number, you will be able to find out the outcomes of the digits which have been highlighted in the blue color of the natural number n, because these are nothing but complements of 10 for the same input, or let us say for the same output. Let's move on to the next step. So the first learning outcome here was what would be the outcome in terms of the units digit of a perfect square. What would be the number of digits in the perfect square of a given natural number? Now please make a note of this, that this is the third thing in the chronological order that a learner is expected to do while you're talking about perfect squares of natural numbers. The first thing is that you should know how to calculate the perfect squares of natural numbers or integers or maybe non-integers. The second thing that you need to know is, once you know the first thing, which is taking your learning to a next level, is you should know what is going to be the units digit of the square of a natural number or an integer. The third thing which is important here is what would be the total number of digits in the perfect square of the given natural number. For this, we will again take a case study approach. And you would see now the 4 different rows that we have taken in terms of the examples. In the first 2 rows, you would see that we are talking about single digit squares. In the third and the fourth row, we are talking about double digit squares. So there are 2 aspects to understand this thing. So the first aspect is when I refer to the first 2 rows in which we are talking about the outcomes of 0 square to a 9 square is either we are inputting a single digit natural number or we are inputting those natural numbers which have a 0 to 9 in their units place. And same aspects you are going to talk about when you talk about the third and the fourth row. So you would see that when we talk about a 0 square to a 3 square, so we had inputted a single digit natural number and the outcome n square also had a single digit, whereas when we talk about a 4 square to a 9 square, then we had inputted single digit natural number, but then the outcomes were a perfect square or were perfect squares having double digits. Similarly, in the third row, you would see that we have inputted double digit natural numbers, but their perfect squares are having 3 digits. And talking about the fourth row in which we have inputted double digit natural numbers, but their outcomes are having 4 digits, which makes us conceptualize this in terms of a formula. And the formula here is if the capital natural number n has small n digits in it, then its perfect square has either 2n digits or 2n minus 1 digits, which can be seen easily in the examples taken in 4 different rows. What is the byproduct of this learning? The byproduct of this learning is the squares of 4 single digit numbers end in a single digit, and here we are referring to a 0 square to a 3 square. The squares of 6 single digit numbers, natural numbers, end in 2 digits, and here we are referring to a 4 square to a 9 square. Squares of 22 double digit natural numbers end in 3 digit natural numbers, and we are referring to a 10 square to a 31 square. And squares of 68 double digit natural numbers end in 4 digit natural number perfect squares, and here we are referring to a 32 square to a 99 square. I hope you would have learned whatever, or this will take you some time to learn, and once you have done this, then we will take this learning or these learnings to the next level.